Hello. We are live again. This is DevStream number 20 about indoor navigation with augmented reality, and I'm creating a template which you can use to do indoor navigation or other AR indoor stuff. I'm using Vuforia, and today I'm gonna work on the custom navigation line. So until now we had this straight line, and now I started to work on this other cool idea that one of the Discord members had. We want to create an animation with like footsteps. You've probably seen this in a game. We want to have the multiple footsteps showing maybe like 2 or 3, and have like this animation that they're walking in front of you, maybe even with sound. But we first to figure out the stuff. Quickly check if the sound is working. Sound, blah blah blah, test. Stuff. Quickly check if the sound. Yes, I can hear myself. Good. If there's any questions, let me know in the comments. I will now and then here and then look at the second stream if I can. And yes, let's go. So last time was a bit a struggle. We updated the Vuforia engine, and I don't remember the second thing, but we got lost in configuring things, and then essentially I was too tired to continue work on this. So let's get a fresh new start. Let me quickly share the link in the Discord. We have a small Discord community where we share experiences about navigation. Stream notified. Sorry for being so late. Usually I stream 2 hours before that, but okay, so, and I gotta show you a new toy I got. Pretty cool. I can we say that share my notes. It's like super fast. This is going over Wi-Fi, by the way. So let's see. Oh wow, it even shows my pointer. That's cool. Hello. Okay, so the idea, so I want to use this a bit as a tool for teaching and showing stuff, also for notes, and I let my kids draw on it, which is fun. So what we have is we have a destination, right? And we have our let's not use a capsule, let's use a guide, because essentially this is you navigating it. Oh gosh, that looks a bit not safe for work. Okay, so this is the phone, but voila. And now what do we have from the navmesh agent? We have the path. This is that. Navmesh agent path. So what do? We have the agent. The agent is here. Okay. And so we have this line. So when I show you in the application, this is only a simulation. But voila. And so here we have this line And here we started already a bit. Yeah, there's still some things not going well. But yeah, so the idea is that you have this line, and then as you walk, you see these steps in front of you. So my idea was to oh, I don't want to hear myself. Okay, so my idea was that we I have to switch back here. So we have this game object. Let me see where it is. Yeah, so there's some weird issue that it's turning at the other side when I'm walking backwards. Oh, maybe because it's taking the direction. I don't remember. But we're gonna look at the code real quick. Backwards, and then when I arrived, yeah, okay. Oh, here it's working. Okay, so this is foot sprints, and this is foot left, foot right. Really simple. So foot left, foot right, the game object, and this is the parent. I don't remember. It was in the AR path visualizer. We still have to clean up a bit because now they're a bit mixed together. And in the end, what I want to have is we have a line visualizer and we have a foot visualizer, and then you can switch in the settings, so you can switch in the editor which one you want. And yeah, but this is only like a demo project, so we try to make it as flexible as possible, so that when you want to implement it yourself, you can either create a fork from this project, from this repository, or just use it as a guide on how stuff are done. Yeah, there's a lot of controllers, a lot of scripts. Yeah. Anyways, so my idea was that here we have this game object, or eventually this is gonna be, yeah, so we have this game object following this line, and we always have this footsteps, boom, 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 along the line. Now, at the moment, what we try to figure out for the first, we have like these problems. I think we already started with this in Paint to write down the problems. Steps. Position along line, fading animation, sound. Okay. Yeah, so it was the last time this weird, not weird, but it was just with mouse. SpongeBob, trash, try. Daisy. Ryan wants to play Daisy. How's your health? Is your health good enough to play video games? Sick a bit. Daisy. No. Ryan was a bit sick. Sorry if I. Okay. Yeah, here we go. So we have the position. Thumbs up. You're better, man. You should be sleeping in late now. Oh no, for you it's not so late. Only 1 o'clock in the morning. Position along line. So when I have this, when I figure out how can we follow this line until to the destination, and then was the animation, so that in the beginning fade. So they fade. They have like this fade animation. So that's basically, that's the concept. Okay. So 6 a.m. is only 6 a.m. No way. Ah, then you're soon going to school. I thought you're 3 hours ahead. Oh, no. More? Okay. Okay. So this is the concept. Now, let's look at this. The thing is that is difficult to handle is that this line, I mean, the line is good, just how to solve this problem. So the line basically consists of points. Okay, it's actually just points, the path of the line is still let me maybe change the color to red. So what we get from the agent is path corners. From the agent, okay? And this is essentially the line. This is essentially what we get from nav mesh, from the nav mesh agent, about the fastest route to the destination. Well, you can play with nav mesh system, how you know it, etc. But and what we created with the line render, or this is not a script that I invented, but this I found in Game Stack Overflow or something. Someone was asking this question. And so this is the line render. Use another color. You can. White. Oh no. Gray. Gray. Okay, so this is the line render. Does this. Now, essentially, if you want any navigation line, you can do whatever you want between those lines. You can spawn whatever you want. You can spawn arrows, you can spawn a path, or you have this line and the shader. That's maybe could also be a solution to this problem, but try this approach first. One user here. I think he showed an animation of navigation path. Yeah, so here's an animated shader. This we could also do. We could try to only have this animation shader running while we walk and only show the... Yeah, so that would be a completely different approach. Maybe we would have the animation only running like 2 minutes before, and then yeah, but so we tried, yeah, so the animation would be a shader. That's also a possibility. For now, we try our approach and see how it goes. El Malem. But this is already going into a really good direction, so maybe we hear from him soon how it is already solved. We don't know. Would be cool. And now when I go back to this, I remember something about try to re-understand this, because essentially we need to find a smooth way to draw the position gradually. It's kind of tough to know where to draw it or where to position it. Okay, so yes. Maybe we should add comments next time when we draw. So there's this first point, the second point. I think. Oof, did it stop? Oh. Okay. There we started. Not showing any notes. Secret. Yeah, you saw the Russian course. Yeah, I'm teaching Russian at the moment. Friend. Good refresh for me. Where did I start it? Ah, here. Maybe there was a timeout. Yeah, I lived in Ukraine for 2 years and learned Russian there. Now I teach a friend a bit of Russian. Good refresh for me. Okay. Can I draw on here? No, it's really just here. Okay, we're back. Maybe I clicked something on it. No, I don't know. Anyways. Make the footprints run, kinda look like in the game. Worry about this later, bro. We can make them smaller, of course. At the moment we worry about this whole system, so I think we created some sort of distance so that they're 1.5. What is happening here? See that? Jumping. Ah, this is running. Ah, this is debugging from the steps. Okay. I was like, what the heck? Okay. So this is somehow... Okay. Let's just go read the code. Ah, feet spawn distance. Ah, okay. We want to spawn the feet 1.5 meters ahead of us. Does that work? New page? Yes, good stuff. Okay. So, back to blue. Foot with... Not my English. Foot with 2 O? Or foot with 1 O? The foot. Elephant foot. Steps. It's because it stands like food. Food. Well, I've completely blacked out. Why do you say food but football? Ryan, help me out. Okay, worry about that now. Okay, so we want phone distance 1.5 meters above ground. Okay, this is similar code to the nav mesh line render. I think this is also the line render here. The line here is still here. Yeah, I removed it. Yeah. We have to draw footsteps and then we loop through the path and say, okay, only update feet when there is a path and it's not the last corner. Okay, the path has 2 or more corners. current iteration is not the last one, or the second last. And they're not positioned yet. Okay, interesting. And then path part distance. Okay, not positioned. And what's the other? Oh, we only have this case. How do we update it? How does it update? If the distance, path part distance. Okay, distance. Oh gosh, what do we do? We loop. Distance we loop through corners. Let's maybe have this and this. Nope, that doesn't. So you have to be... perfect. Okay. So we have the array. We have the array of positions, so this is think of this. So why that? Yeah, we have this in the path corners. It helps sometimes a bit too. Ryan left the chat. Being lazy? I don't know. Okay. So then in the for loop, we loop through these. Okay. And each corner, we're gonna calculate the distance between one corner and the next. Okay. So we have one corner. 1, 2, not question mark. 2, then. So this is taking a vector 3, this, and then we have path part distance. Okay. Oh wait, let's actually an erase by selection. This is quite cool. Boom. And then we can also move stuff. Okay, so this is this. Let's remove the lines. So this is the path part distance, and then 3, 4, 5, and then so let's call this y2, 3, 4, and y1 plus. This is the distance. So here we have the total distance of the current line. This is what it's logging here. So here we have the Actually, I want to have this visible to see if the stream is doing all right from YouTube. Okay. Oh, we need to go back to this group. I like this that you can switch back to the group, not just one and then select the other again. Okay, so this is the total distance. And then we say, okay, if the distance is smaller than the total distance, maybe rename this total path distance. Oops. And by the way, today is the first DevStream standing. Kind of helps not get so tired. Or fingers crossed. Okay, total path distance. So then we have the feed spawn. Yeah, so if the total is smaller than feed spawn distance, we don't want to show the footsteps, okay? So actually, if we arrive, why is it turning around? Something we have to figure out. Debug. Or it can be warn. Warning. It's not a warning, but just that we see it better. Path small. Okay. If this is not the case, so obviously it's bigger, the same or bigger, then we create a vector, an empty vector end position. And then we have another if case, if switch statement, not a switch, it's a if statement. The partition is smaller than our wanted spawn distance. Yes, same, it's obvious. The part. Okay, if so, this means this one. Okay. So if this is smaller than spawn distance, let's maybe create a second row. Also scroll down. Oh my, I see my tip is already degrading. The kids on the weekend are drawing a bit. So this is the. Let's only just call it Y. Y. So if this is smaller 1.5 meter, then what do we do? This part is longer than spawn distance. Why? Smaller. This path part is longer than spawn distance. Did we do this wrong? Or maybe the comment is wrong. No. Distance is same further than spawn distance. So this is about the current. It's always looking from the current one iteration of the for loop, checking the current or one path corner up till to the next. And what is it doing with feet positioned or not? Once it's positioned, and how does it get updated? Aha. Every iteration it's getting. Aha, every time it gets positioned new. Okay. Makes a bit sense. Okay. So, just have to figure out this part. What do we do? End position is current path corner plus the next one, up by distance. That point between 2 points by x distance. Aha. Between 2 points. That might be the problem of the backward. Okay. So it's between. Aha. But that only works if we're more, so must be this way around, no? So if the part distance is, if this is, yeah, that only makes sense in this case. Let's create a bit more space. This is however. Yeah, so we have this distance. And if partial distance, no, we say y. If y is smaller, no. If it's bigger than 1.5 meters, then we can just say, okay, go from point 0 and 1 and take the fawn spawn distance. So we go from here, 1.5 meters, boom, here's the endpoint. I guess that's what the endpoint is. Endpoint. Or actually here I want to spawn it, so this would be spawn point, right? Endpoint. Call this spawn point. Spawn point. Okay, yeah. Okay, we rename it here too. Music and voice is okay. Might be a bit loud. Let me know. Okay, so this is case number 1. That's the easy case. Easy case. Great. Now the harder case is when we have short, when it's going around the corner. So then y1, y2, y3. For example, y1 smaller. You can have to write it. You can just say okay. Smaller than 1.5 meters. They're all smaller than 1.5. Now we have to find. Now we actually have to find the distance. Maybe here we need another for loop. We have another for loop. How is it solved? Distance is same or further than spawn distance. Ah, so here. Oh, interesting. Aha, so in case this happens, then we don't do this stuff, right? Then we position the feet, spawn point, position, look to the next corner. We turn it so that it's looking into the next corner. And then look at and position true. And then for the next, then I feel like for the next, then we can jump out of the loop, actually. Will, because it will just loop through it without needing for it, but how do we jump out of the, can we jump out of the for loop? Just by, is it just return? Jump. Break. Which did? Okay. I'm pretty positive we can set it activate. Then it's positioned for the current state of the. Yeah, then we might not need this anymore. Ah, I recognize that. Okay, interesting. Think so. Is there an else for this? No. Doesn't do anything. Aha. So now we're just looping through. Okay, yeah. So if this is the case, I don't really like it so much that we go through this all the time. We could just come here and continue and make another small nested loop. I don't know what's nicer to go through. Nested loops are kind of nasty, so in general, so let's keep it this way. I'm gonna write in stream chat. No. Let's do it this way. Let's leave it this way, and let's look at the hard case now. So we have the previous distance is calculated by total path distance. Is this total path distance minus the path part distance? Previous distance. From what? Maybe it's from the last iteration? Maybe from the... Okay, so we loop through from the beginning. Let's see. We have this distance, y1, and this is, let's say, 0.8 meters. Now path part distance is 0.8 meters. Total It's also 0.8 because we are looping through and adding it up. Debugging your own code. Called. Total path distance. So we take the total minus path part distance. So previous in this case, let's say 1. So previous 0. True, because we just started. And then we calculate the remaining. Aha, interesting. Maybe a nested loop is better in this case. And the remaining distance. What? Distance is 1.5 meters. Minus previous. In this case, 0. New. Previous. Okay. In this case, remaining distance would be 1.5. And that doesn't sound right for me. Because then it takes the corner 0, corner into the next corner, and then gonna create, it's probably this weird effect that when we go around the corner. Yeah, no, that doesn't add up. No, that doesn't make sense. The better thing that I think of, the better way would be we create a nested loop for this case. For this here. When we realize, so at this point we're here and we check this distance, right? Path part distance. We realize this is too small. And then we start another for loop and we go through. And in every iteration or at every point we check, okay, is this now 1.5? Is this current distance now 1.5? And if it is, let me check. But how do we know when it's good? That's what I don't get here. Like, this is not bad. Maybe it... Because in this case, when it's smaller, then we should just save the current distance in the previous distance. I think that's what we do. No. Should save the path part distance in the previous distance. And then go to the next iteration. And check again. And then we take the remaining distance. So maybe it's thought like this. Okay, maybe we can do it without nested loop. So okay, we know this is 1.8. We save this to previous distance. Then we go to then in the next situation when we come here, we still have the previous distance and we have the current. And then we can say, okay, when this is, say this is 0.5 meters. So this is, no, let's have, there also have two cases. No, that doesn't work. We'll have to work with an array. Just in case it's multiple entries. Could also check for every trying to think of ways we could do it. I don't remember what this algorithm is called, but what we could do is we check the corner, check this, we make a what's it called? An algorithm that calls itself recursion. Does it work with recursion? I'm not sure, but here's the idea: that we go through it here, check. Okay, it's smaller than 0.8. Then we go here. Say this is this. Say this is 0.5. Then we are at 1.3. This is still smaller than the actual distance we want. And now from here we have, say, 2 meters. Oh, we have 1 meter. And now we should know. Oh, okay, so in this, somewhere here between, we need to draw it, because the total distance is longer than, well, not the total distance, we need another variable, total path part distance maybe. Or is it doing this? Aha. Total path distance is not the total, like the current total. Okay, just good to know. So this is adding up while we loop through. Aha, yeah, that's true. So this is adding up while we loop through. And as soon as we hit I feel like there's a logical error here. Yeah, there's one case, like in this. I hate math. That's all about programming. It doesn't really have to do with math. It's more like logical thinking at this point. So we have this distance, we have this distance, we have this distance. Ah, can you see it? Yeah, cool. Don't even have to draw, I just point it. So we gotta know when do we have to draw. From here, the idea was that we have this, for example, okay, here is wait, 1.5, So this is until here 3, and then here we still have to do 1.2. Then we have 1.5 in total. Okay. This is probably the remaining distance, like, because we're gonna use the lerp distance between those points, then subtract here probably. I don't know. One last thing before I leave out the 4 by. Thanks, man. Have a good sleep. Or no. Have a good time at school. Time. Enjoy learning. Okay. This is easier than it is. Oh, looks easier than it is, but my brain is fried. Josh fried chicken, not Kentucky fried chicken. So this is the current, and the path part distance is, so this is the current distance that we're looping through, yes? And this is the distance from current point where we are. So if you're here, we do nothing. Is it smaller? Yeah. Is it so? Then if you're here, okay, this is also smaller, we do nothing. Okay, and then I think this case only works if you're within 2 and it works, but it would work for multiple, because if you have a sharp corner, it might have multiple corners. So we have to accumulate this somehow. It's accumulated in the total path distance. So here we actually have to check for the path distance. Need to access the previous distance. Yeah, it's forgot about this. Just rethink. So at this stage, we know the path part distance. Let's just write it out. Brain. Path part is smaller than bond. Then we check if, so there are 2 cases. Either is the so we know it's smaller. So we check if the total path distance is smaller and feed spawn distance. So if it is smaller, we want to skip the iteration, right? We don't want to do anything. We just want to add this up, but this is done here. Still. Now how to skip iteration. It's like stuff, but no. Skip, but if you're programming in so many languages, it's hard to know. Skip loop iteration. Ah, continue. Yeah, right. Continue saving breaks on one iteration if it's better continues. And next iteration of the loop. Continue. Thanks. Thanks, Jason. Continue. Okay, we just want to continue. And then if the total path distance is bigger, same or big, then we need this remaining distance. And the problem now because the problem here is now, this would be this case. I'm at this position, and for example, now we have in. So let's look at this case now. It's 1 point. It's actually the third iteration. We have total spawn. Total part. Total path distance, we call it, yeah. Total path distance is at this moment. Aha, wait, no, it's not interesting yet. Oh, maybe it is. Wait. Ah, yes. Because we always look at the next. Oh, come on. Have a timeout. Have it. Server closed on us. Or whatever, I don't know. Yeah, cool. Oh, now we're in red. Whatever. Total path distance is at this point. Ah, yeah, because we have always to the next path, okay? So at this point, if this is 1 meter, total path distance is 2.3 meters, okay? Which obviously is too much. Now the problem that we have, that's why you take previous distance. So this is the total path here now. Even though I have to add, it'll be longer, huh? But At this point, when we loop through this part, boom, this is 0.3 meters. Imagine doing this with paint. Jason writes me in Discord, oh, you should look definitely into a shader. Maybe. Maybe that would be better. Well, if we figure this out, let's see. And then we find out in shaded it might be easier. Okay, so at this point, we have 2.3 meters, and then the previous distance we calculated with the current total minus the current part. Current path part distance, maybe this is the third time. Path part distance. And this is the current. It's not the total path. Current. Path distance. Path distance iteration. Iteration tool. Too long, but then we at least know what it is. Okay, current iteration total. Okay. This is like, okay, we take this total minus this. And then we have this distance. Oh yeah, now I get it. Luck? We haven't yet. So we have no, this is previous distance is in this case the total, so 2.3 minus the current one, so 2.3 minus 1 is 1.3. And then we want to have the heat spawn distance. We say heat spawn distance is 1.5. And then we say 1.5 minus 3 is 0.2. And this is this one here. Okay, and then we go from this corner here to the next corner, and we'll lerp by 0.2 meters. Okay. Ryan, I'll send you my math assignment. You didn't press Alt F4 now. Well, if you pay me for your math assignments, I'm fine with that. I'd like to get paid in Swiss chocolate. Or in pizza. Pizza also works. Okay. But We only want to do this if we're good to spawn, right? If we're not good to spawn, we just switch to the next one. So this is the mistake that was done before. Hope so. Mission defeat. Ah. Yeah, if this is not the case, we're gonna... Anyways, let's see if this works. Bro, this was all just boo-boos. Let this compile. How long are we streaming now? 1 hour to figure out a small for loop. And now we didn't even handle the case when it's too small. Then we should deactivate it, right? We arrived. Yep. So, kitchen. Here we go. Ooh, why was it jumping? Ooh. Ah, now we go the other direction. What the heck? Ah, this is the path visualizer. This one. Probably. Oh no, this is the normal line renderer. Yeah, so we have to still figure this out, how to do this smart and switch between them. What is happening here? Yeah, now I messed it up. Oh, power pointer, that's not good. Ah, maybe because we deactivated it. Okay. Ah, this is only the in view. Kitchen. See, 1.5 meters may be too big, too much. Eventually, I want to spawn 3 of them. Oh, this is a jump. Why is there a jump? That's not good. Anyways, we fixed a few issues. We fixed the issue that that it's going backwards. Okay, so that was a small logical error we did. Can you please quickly, in few words, explain what you're making? Hello, Peter Blazinic. Okay, so this is a indoor augmented reality indoor navigation app with Vuforia. And this is essentially what you see on the phone. You would be in an area at your school or whatever place. You would have to scan it first. And so this is a mobile app, and this is just a simulation of the environment you see. And this was previously scanned, and then the Vuforia engine is mapping the scan with the current data of the camera view. So you would have to think, if you had the phone in your hand, and then you would walk through the scene and you would see this line, you would not see the additional. This would just be video feed from the camera. And then you would see this line. It will recognize where you are, and then you can walk. You have a destination, you can select up to destinations. And so what I'm creating is a prototype of this. And now what I'm creating at the moment is his weird footsteps. Until now, I just had this line, and one Discord member he wanted to have that of the line. He wanted to have footsteps. At the moment, I'm working at a animation to draw these footsteps. Obviously, this is just the first kind of steps to position the game objects correctly. Later, we want to have footsteps that are like walking as an animation before you, in front of you. Yes, so this is what you're doing. What we're doing. Yeah. This might be... The problem is... Does that work for you, Peter? Yeah, so at the moment I'm creating an animation of footsteps. Are you working in AR indoor navigation as well? How what? So this is Unity, and we can deploy to Android and iOS. It's pretty cool. On code base. Okay, so problem we're facing now is, or I'm reconsidering you should do this like this or with a shader. I don't have so much experience with shader, but maybe that's the day. Get it. Well, not today anymore, because the stream is running late. Oh, in, but still already late. What I have to think, yeah. Then when we arrived, everything's going nuts. Because the thing, okay, we figure out the problem that we had in the for loop. A few adjustments, and we renamed the variables. Fix spawn position, or improved. It's not all the way fixed. Why you're marking this? Because I have a German. God. I'm just web dev, but your live popped out, so now I'm intrigued because this looks so cool. Yeah, check out the other videos if you think this is something cool. I also mainly at my workplace or my employee, I am doing mostly web stuff or web. I consider myself a web dev. Mainly we're using Vue.js at the moment, and Capacitor and Pinia Store and stuff like that. So create apps. We create apps with or we create iOS and Android apps with a web stack, which is pretty cool. So web developers can create web apps, create normal apps too. Pretty cool. Yeah, so this is a pain. You would laugh how to make these buttons. You would laugh so hard from how I create these buttons. There is the possibility to create UI with HTML, but this is essentially you. I can. this. So essentially, this is they have their own components. Now we don't want the session recorder. So these are all game objects in Unity. They're called. Kind of the UI is built up like a 2D game. Think of it. So you have a spawn point, which is here. And then I have a list item which I spawn, which is generic. So this is a prefab, they call it. You can reuse it. Then you can fill it with, set the label here, you can set the label here, you can set the label here, and then have a go to action here. And then you have like scripts, and each script has their intelligence programmed. So here would I say, okay, go, and then call the navigation controller, which is somewhere here in the scene. Yeah. Programming UI in Unity this way with the canvas is a big pain. So I'm looking forward to when I replace this with normal UI. But the cool thing is now about the augmented reality is that this is 3D. So let's get out of this. Let's go back to air target. So this is essentially a 3D space. We can put anything, what we want, everywhere into this space, and while you walk around showing it, you can control that stuff. Getting late in my conjuring. Good luck with the app. Thanks, man. Thanks for dropping by. Cheers. Okay. Was this the end now of this approach? Show you this again. What this? This is the live stream inside. I want to show the Discord. Ah, this again, yeah. Maybe you also find a tutorial about footsteps. Here, I'm not logged in. Footsteps and no, a footprint. It's not footsteps. It's footprint animation Unity. Ah, yeah. Yeah, he does it on the character. Ah, maybe we just have a character and where it touches it. No. Ah, that didn't sound. That's cool. You hear it? Not so loud. Write it together in English. Maybe. Sync effects with footsteps. Sounds like
tutorial today. This is something that I really think is fun. It's a feature I've used in past games, I use it in my current game, and I think it's a little bit obscure too. It's been in Unity for years, but if you haven't gone looking for it, you might not know it exists or how to use it. And the feature we're going to be talking about is animation events. So what are animation events? You might guess this from the name, but they are events that happen at a specific point in an animation. So instead of starting something at the same time in your code as you switch to an animation state or however you do your animations, this actually is triggered by the animation itself as it's playing. So you can basically do anything that you need to do in code but sync it up with the animation. So I'll give some examples of ways I've seen it used. So the first one I think is the most common, and it's the one we're going to be doing as a demonstration, and that is syncing up something with footsteps. So you may do like a little puff of dust, you may want to play a footstep sound, specifically when the feet touch the ground in the animation. So that's what we're going to do today. You may also want to play sounds along with other animations where you have certain actions within the animation that should make a sound. So for example, if you have an animation where the character lifts the sword and then slashes it a few times, and you want the sound to play during the slash, you can use animation events for that.
Yes, at some point we're also gonna.
So you could do these things.
We're also gonna need the animation events if we're using animation. At all, but we have to figure it out with the animation shader. Elmalen, if you're watching, let me know how you did this. Eventually what you want to have is you want to have left, right. And we could always have this animation running. Have to bend it, and if it's bended, my problem about animated, I think this is the line renderer. If this is the line renderer, and if it's just a straight line, this works perfect. Then if you go around the corner, what's gonna do? I've seen this. Either it's doing like this. Wants to show you the line. Can you send it to world space? It will bend so that for you with the camera looking at flat. Okay. Oh, it's here. Okay. Here. Okay. Well. Also works across because it was in standby mode. I don't know. But I also feel like with this, maybe we overthink the problem. or we are close to the solution. I don't know, but what I'm worried about, for example, here is I don't want that the steps just suddenly go. Let's be like a and the animation also has to like be synchronized with the speed that I walk. Like if I would walk, then the steps, they don't move. Once they're placed here, they're fixed, they don't move. Like it is right now. This is just this is just the weird movements that it's making right now. But maybe we're still on a good path. Essentially what we want, probably, or if we continue this approach, we don't update them. Yeah, I don't want to update. Once placed, I don't want to update them. They're fixed. Then we don't open decision. We spawn them, or we always update them, the one that is between. So the idea is maybe this is the first thing. Position is good. I don't know yet. Still worry about, like, okay, it's following the line correctly. Good. Now what we need to think about is that the footsteps are placed one after another, and when. So for example, catch the tablet. Yeah, it was only 7% when I started, so that's why I plugged it in, just to be safe. So once spawned, we don't want to update them. What do you want to do additionally? We only want to update the next one. But how do we know that we moved? That's the other difficult question then. This is probably quite crazy because of. Yeah, don't worry about that now. Yeah, let's try continue to pursue this approach. And see where we go. We try to do this next, or figure out first. Because this is a longer line, why is it jumping from here to here? Probably because the line is getting shorter here, but we're looping through each time. See how we're jumping from here to here? That's not logic to me, because up. This looks like 1.5 meters to me, right? Or in theory. So this is like, okay, this distance. Now go closer. This looks too good. This looks so good. So this case, this is much further away. Okay. Now why is it doing that? We don't know yet. Let's read. Are there any? How do we follow this? Once it spawns, it stops. Now what is this case? So we have Wait, do we have the line? One, two, three. Oh, wait. We have one here, one. So these are the path corners. So we have two here. 1, 2, 3, 4, 5, 7, 8. Should be 8 corners. 9. Okay. Maybe there's one in between. Oh, we can actually locate them. 1, 2, 3, 9. Okay. 1, 2, 3, 4, 8. Wait, what? 1, 3, 4. Ah, there's 2 here. Okay. Maybe that's what it's confusing. Why is this happening? Should not. It should not. It should spawn before because we have like. Maybe because here. I have this hiccup, sorry. Not hiccup, but here. So the total distance here is that okay. Does it have to do with the check? In this case, it's smaller. If it's too small, continue. If you're good to spawn, we take the path distance iteration total minus the current path distance. I feel like it's happening that we go from here. This looks like 1.5 meters. So why would it go from here? These cases, let's try multiple. These cases, it also seems to work. But here's interesting. Here, wait, I know why. Probably because we're going through. And we go through this first. Current path distance. We check this first. Check this first. If the current path distance. Yeah. If the current path go from here. Ryan Steve. Yeah. Get it now. The problem is check first. Is the current path part distance bigger than heat spawn distance? And then we spawn it. No question asked. So we loop through probably. It is smaller, and then suddenly we're here. And boom, it is bigger. And then we spawn it. But actually, we are in this iteration. So maybe we need to maybe we have to have a flag here or avoid not go into this case if certain condition. Yeah. So, and maybe if this previous distance is previous distance is what? Previous distance is not calculated here, so we don't know it yet. Wait a second. Okay, so we need to check this case somehow that in the next iteration we don't go into this. That's not go into this here. Previous distance. If the previous distance is how do we know? How do you know? Oh, we can assign the previous distance up here. Or we just set a flag. Or we can find it out from the previous distance. If the previous distance is still smaller than the spawn distance, that makes sense. The total distance. The current path distance. This is just checking the current path distance. Wait, is my stream gone? No. Rolled. Give me health. Still excellent. Okay. Why doesn't it say good anymore? Okay. We're still alive. And I have sound, right? Yes. Don't have music anymore. We're here. Okay. So we need to check this case. Previous distance. So this is the current path part distance. What's the problem? Oh, now we stopped it. Bummer. Does it work backwards too? Yes. Still useful, these corners. I realize now. Cool, I just thought it's something to do for making it more visible, more understandable, but I think this is quite useful. So maybe create a so what we could do with a simple approach would be let me see. Sorry, this better this way, I think. Path is path under construction now. Is path falls true when looping over multiple corners to build path. So as soon as this is the case, we set this to true. And as soon as we spawn it, pause again at here and path not okay. Like that. Test. Ryan sleeping now. Let's test. Dang it. What happens? Save. Maybe because void and then we overwrite it maybe. No, as long as we don't move either. Must be this case, yeah. Wait, why can we cannot? Yeah, so it's always weekend spawn, yeah. Why? Are we resetting? Ah, we reset it in Alex. No, we loop through. Every loop is standard. Yeah. But this happens like once a second. Yeah, we also have to maybe think about when to call it. Apparently this is done in a coroutine. I don't know how often this is called. Once per frame. Interesting. It's not even going to this calculating, not. Why are we not seeing this one? Then it should go here. Ah. It is a bit smarter. In your so corner. Oh, I see corners everywhere. Let's see if it still behaves the same. Should behave the same. We only made it a bit cleaner, the code. Surprised we never get into this one. One, two, three. Yeah, so this is the case. I'm surprised we never go into here. How does this work? F part is smaller than spawn distance. Aha. Iteration total. Of course, at this point, this is never too small. Here, we already know the current path part distance is smaller. Okay. Aha, yeah. Normal. Not good. Current total iteration, or not of this iteration, of all the iterations. If this is smaller, but why do you never get in here? I mean, where is this? Where do I write this distance? Ah, here. That's distance iteration total. Yeah, this is. Yeah. One, so it's going through 0, iteration 0, 0.5, 2, 0.75, 1, 0.75, 2, 0.1.2, 0.2, 1.4, then we spawn it. But why the heck? Do we not come into this one? Cannot spawn. Ah, we jump out of it. No, then we would see this. No, this is total. Small. We never see past small. Nope. Maybe we overdo it with the footsteps, like it's a coroutine, right? How does this work again? Is this done once per frame? 30 frames per second, then we have 30 times this for loop, which is a bit too much. Too many questions. But my main question is, why do we not come in here? No, here. To go in here, we do this. Yeah, let's see. This case, see, in this case, for example, we have 0.0. So iteration 2. Distance is 1.02. Okay. This is the distance. Let me say this tomorrow and we continue. Well, what does continue do in this? That's also a question. We jump out of it totally. Maybe don't have enough time to write this. No. Oh, what's this written again? Cool. Okay, they work out multiple frames. wonder if that has to do something with the coroutine, but hope not. But take this away. Curious about this. Because essentially distance is smaller than speed spawn. So that's maybe also a mistake. So we just go to the next iteration. Which essentially the same is here. That's why we never come in here, because this is the same. But why doesn't it write this? Weird. Maybe because we blocked warnings. Idiot. Yes, it is the same. Okay. Wow. Okay. Do we have to handle this separately? Let me just... yeah, if it's already done here, then we do it here. Wait. That means it never gets here. Wait. Let's redo this how it was before. In this case, we never really get to this. Which is okay. But now, how do we handle it? I don't know why it's not. Yeah, I was not writing this because of the warning. So it was filtered. Filtered away. So we do this here. But you don't need it here. But this case, we want to know if this is happening. Yeah, so we set this, yeah. In the case it is longer, then we know, now we're calculating it. Yeah, that's good. Yeah, this. But then we don't need this anymore. That part is smaller. Path part is long. Path part distance. Just this away. Boom. Yep, that was a mistake. Oh, it's not jumping anymore. Yeah. Okay. Yep. There we go. Problem 1 solved. Placement. Jumping anymore, that's good. Okay. Hard to move and watch on the left side. Okay. Yeah, that looks better. Okay. I think problem 1 is solved. Now we still have to... Yeah, I think this is good. Get rid of all the logs. Those. Not using this at all. Why it's marked. Ah, this is from the line, yeah. Just for a simple, yeah. Just jumping the okay. So we fixed this part here. There's no green, unfortunately. I have black, gray, white. And by the way, on my tablet, I just see it. I don't know if you see it. Yeah. It's just black and white. It's a bit shaded, so I see the difference when I draw it, but here I don't see any colors. So the earlier version of e-ink, you just had a bit of a gray shade, different colors. So I see that here on the right, for example, it's a bit lighter than here and here. But yeah. So position on the log line. Oh, let's not make it boring. Let's have a done. Okay. Then the next thing will be not animation. Play. I guess the position along the line is good. I'm out of this. Okay. What we want now is that the footsteps are spawned like a game object spawning, or we have three of these, and then we spawn them and they're not like moved. Don't wanna, they should be like walking, not like not like a tank. How should we call this? Not moving, no, actual walking. let place. Okay. Let's have a mark here. Okay, good stuff. Thanks for watching. I think I'll leave it here. Are there any more questions? No, Ryan is finally sleeping. And I'll be sleeping too. Cheers.